Hey, welcome back. Today we're going to solve another LeetCode question called 2sum2. So we previously solved 2sum1, link in the description, and this one is a follow-up. So as a reminder, I will be solving all the questions from blind 75 list. It's like 76 questions. So yeah, subscribe if you want to know all the solutions and explanations. Let's start. So 2sum2 input array is sorted. Let's see. Given a one-indexed array of integers numbers that is already sorted in a non-decreasing order, please find two numbers such that they add up to a specific target number. Let these two numbers be numbers index 1, blah, 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 blah. Return the indices of the two numbers index 1 and index 2 added by 1. Okay. The tests are generated so that there is exactly one solution. You may not use the same element twice. Interesting, your solution must use only constant extra space. Okay, let's go through the examples together. Example 1, numbers 2, 7, 11, 15, target equal 9, output 1, 2. So we said that this is a one-indexed array, which means that the index are 1, 2, 3, and 4. Target equal 9, so we need to find two numbers that should add to 9. We see that it's 2 plus 7 equal 9, and the index of 2 and 7 is 1 and 2, so the output is 1 and 2. So far so good. Let's see the second one. So we said it's 1, 2, 3, 2 plus 4 equals 6, and so it is 1 and 3. So the output is 1 and 3. And the last one, minus 1. So it's 1 and 2, minus 1 plus 0 equal minus 1, which is the target. And so it is 1 and 2, and the output is 1 and 2. Okay, perfect. Let's talk about possible solutions. So we will talk about two solutions. The first one is brute force, and the second one is a more efficient solution. So let's talk about the first one, brute force. We have the following array, 1, 2, 3, 4, 10, 11, with a target 7. Brute force means that we will try all the combinations possible. So if we want to do that, because we want the sum of two numbers, we will have two for loop. So like for I in something and for j in something else. So let's see what we can do. Let's say we start with 1 and then we go to 2. 1 plus 2 equals 3. This is less than 7. This is not 7 because 7 is a target. So then we go to 3, so this is 4. We go to 4, this is 1 plus 4, 5. And then we go to 10. We have 1 plus 10 equal 11, which is actually more than the target. So we know that this is not going to work because, as a reminder, a number is a sorted array. So we should be able to stop, but because we are just doing a brute force solution, we will continue. And 1 and 11, 12. Same, this is useless. So now, if we do 2 and 3, 5, so this is not target, 4, so this is 6, and this one is 12. So we are already past the target, so we shouldn't continue and see 11. But because we are doing a brute force solution, we are just doing that. So we have a sense that we are not using the fact that numbers is a sorted array because in a lot of cases, we should be able to stop before, but we are continuing past the target. So let's continue the algorithm. Let's say we are now at 3, and we have 3 and 4. 3 plus 4 equals 7. So we found the solution. And because they say that there exists only one solution, we should be able to stop now. So now what we're doing here is two for loop, one inside the other. So here we go through n element, here we go through another n element. So the complexity is O of n times n, which is O of n squared. So now let's talk about the second solution, the more efficient one. So we still have the same array of numbers, 1, 2, 3, 4, 10, 11, with the target being 7. So we want to use the fact that numbers is a sorted array. We previously saw on the brute force solution that there were some numbers that we didn't even need to see. For example, like 11, because we knew that, for example, 1 plus 10 equal 11, that is more than 7. So let's try to see if we can use this information. Usually when there is a problem with sorted arrays, we use something called two pointers. So we have a left one and a right one. And we will be playing with these two pointers. So at the beginning, we have left plus right. It's 1 plus 11 equal 12, which is more than 7. So now we can do two things. We can either move left to the right or the pointers right to the left. We see that currently it's 12, which is more than target. So we should decrease right by 1. So like right will be here. Because if we increase left to the right, then it will be 2 plus 11, which is even more, and that's not what we want. We want to decrease it. So now we have, so at the beginning we had 1 plus 11 equal 12, which was more than 7. Now we have 1 plus 10 equal 11, which is still more than 7. So now we should again decrease the right pointers by 1. So right will be here. So we have 1 plus 4 equal 5, which is less than 7. So now we should increase the left one by 1. So now it is this one. So we have, 2 plus 4 equals 6, which is less than 7. And we will increase again left. So we have 3 plus 4 equals 7, which is, well, equal to 7. So we have our solution. That's how we'll do. And now that we have decided, it's pretty easy once we understand how the pointers are working. You will see in a second that the coding part will be super easy and very straightforward. Let's see that. So let's do the coding part together. We said that we wanted two pointers, left and right. So left start at 0 and right start at length of numbers minus 1. Okay, so what we want to do is we need a condition to stop. So while left is less than right, we want to know if sum is equal, less, or more than target. So let's see, sum, it is numbers left plus numbers right. Let's see the condition. So if we have s equal target, then we found the solution and we can just return left plus 1, right plus 1, and we do plus 1 because it is one index, so it's written added by 1 as an integer. Okay, I don't know why. Else, if s is less than target, it means that we should move left by 1. So left plus 1, else we should move right to the left by 1. And that should be it. So let's run it and then we'll go through an example. Okay, what was submit? Okay, perfect. So let's run an example together. Example 1, 2, 7, 11, 15, target 9. So at the beginning we have left at the most left and right at the most right, so 15, and we see that sum will be equal to 17, which is more, so right will be moving to 11. And now we have 13, which is still more than target, and then it's moving here. And then we have sum equal 2 plus 7, which is 9, which is equal to target, so we return the correct answer. Now let's talk about the complexity. So for the space, we see that we don't use another data structure to store lots of for example, another version of numbers or this kind of thing. So this is O of 1, and the time, we see that we go at most one time through all the numbers, so this is O of n. So this is it for TwoSum 2. I hope that was helpful. As a reminder, we'll go over all the questions from line 75, so don't forget to subscribe, and yeah, see you soon.